Hi, today our team is going to present to you our business idea of AI's involvement in return logistics. While we were doing our research, we realized that there was a total loss of 729 billion US dollars regarding the operations of returned products. And once we digged into the data, we figured out that 44% of that was from textile products, from shoes and clothing. And that's why we decided our target market should be textile products, and specifically imported textile products, because the shipping from one country to another country is the main cost regarding the operation. What do we offer? We offer an AI-driven extension for major large e-commerce companies, and our target area is all around the globe. However, for further parts of our presentation, we're going to focus on the city of Toronto. So our business plan integration is involved 3 steps. First being determining the optimal warehouse location, and then collecting the returnable products into the warehouse, and finally an AI-empowered automated email system for customers who might actually buy the product. So our key stakeholders, we have 3 third-party logistics companies and consumers in high influence and high interest. On the other hand, we have the AI and data analytics companies in low influence and high interest. And finally, the government regulators, despite not having high influence, despite not having low interest, they have high influence because of the data policies. So, but at the end, how much do we save? So we had 729 billions of USD in loss total. And shoes and clothing, we know textile products occupy 44%. And then we have our scope in the $320 billion of USD. That's what concerns us. And the major losses are transportation, labor, and storage and warehouse costs. And once we check the percentages, we figure out that the most cost in the return logistics is the transportation. And this translates to this amount of USD. And another important detail is the carbon footprint, which is 1.5 billion metric tons in 2024. We aim to reduce all these reduce the transportation by 60%, and there will be an increase in labor and the warehouse costs, since we aim to open new warehouses and hire new people. By reducing by 60% the transportation and increasing these 2 criteria, they're going to be these are the predicted costs that we're going to have at the end, which again translates to a final save of 196.15 billion US dollars, and a total cut of 1.3 billion metric tons of CO2. That being said, we're now done with the business presentation integration, and we're going to continue with the breakdown of the code for the warehouse and for our AI integrated system, and we're going to end our presentation with our UI UX interface in Figma.
In this part of the presentation, we're going to talk about our warehouse locating code. Our code mainly locates the best warehouse in the city of Toronto according to our data. And in order to write the code, we use Google AI Studio, Gemini, and Colab. And use the data in City of Toronto archives and convert it into synthetic data because of the lack of information and also privacy concerns. In order to process the data, we use generative AI and convert it into XDAF file. We used 5 key parameters in order to do that. The first one is population between 15 to 64, because we wanted to target the areas with an active consumer base. The second one is purchase and return density, because we wanted to prioritize areas with high shopping flow. The third one is median total income, because we wanted to aim the well-to neighborhoods. The third one was then availability and cost, because opening a warehouse is expensive and we wanted to reduce the rate of doing that. The fifth and last one is transportation services, because we wanted to increase the accessibility of our warehouse. This is the hierarchy between the parameters. Let's read the code. This is the first segment of the code, which reads the data. We use a weight formula in order to do that, and you can see the weight defining procedure in this code. This is how we print the output. This is the output that we printed. It finds the 5 best warehouse locations according to the parameters. And we can see it in the graph.
Hello everyone, now I will explain our AI-driven notification sender system. So our system uses an advanced natural language processing system which is powered by all Mini LM L6 V2. So we have two different notification systems. One of them is the basic one. It basically just takes the returned items category as the input and use the semantic machine and the machine learning process to check if there is any users who are closely related to that product, meaning the returned product is their most visited category, and then sends them a notification. Here we can see that our code checks the Excel file and determines username and user ID and converts their address to the latitude and longitude for mathematical operations using the nominating tool. So the second part of our notification system is the AI enhanced recommendation. It basically tries to find other users who might be interested to that product, and our all Mini LM-L6 V2 tool enables that by comparing the returned product and the other users' most viewed and visited category with 384 dimensional vector space. So now we will check our semantic machine learning. So we defined a taxonomy to make our AI job a little bit more easier and more efficient. And here's the predefined pre-function to train our AI model. And then this is the main function that we train our AI. It used the build training example with taxonomy, which was a previous function that you have seen, and the all Mini LM L6 V2 tool, which is a sentence transformer. And now the other important thing is the location-based notification. Here, our AI sends notification if the user is only in the range of 20 kilometers. If the user is not in the range of 20 kilometers, the user won't receive any emails. So now we have an example of our output, and then here the return category has been selected as luxury design wear randomly, and then these 4 people are the only people who will receive the "this is your favorite item," and the rest is the AI enhanced notification, as you can see here. And then here is the location of each user and the distance between the warehouse and the user.
In this part of the presentation, I'd like to talk about how our team envisioned the user experience and user interface could look like. Now you have a clearer understanding of how our code works, how we decide on the warehouse locations, and how we choose the people that we're going to send notifications to. So if you're a person of interest close to some of the warehouses and some products are returned to the warehouse, you'll get a notification and it will look something like this as been envisioned. Once you click on the notification, it will directly take you to Amazon. So this is Amazon's website as you see it on your phone. To avoid complications, we didn't design a separate app. Rather, we designed an extension that is right here, and when you get notifications about return products, the user can choose to click on the hub and it's also Amazon Hub. So this is a map of your city. In our case, it's Toronto. It could be implemented in any city once we have the necessary data. And then you're able to see the warehouse locations as decided by our code. You can decide to click on any warehouse. Let's click on the one that is closest to us. And you can click to see the products that are available in that warehouse right now. Since we're trying to cut the losses of the e-commerce company, we're trying to keep the flow of the products. So the customer does not have to pay full price to buy these products anymore, because we have cut the products, and we can use some of that money to give discounted products, which will increase the flow of these any product. For our case, we have women's fashion and sports and outdoors. And if you decide to add anything to your cart, for example, this sweater, it will take you back to Amazon's website, keeping a clear and cut to the chase design. We're hoping that with this design, we can eliminate the losses of the e-commerce factory from the returned products by keeping them in close proximity to users who might be interested in them.
Okay.